Okay, so we went through the proof there. As I said, you don't need to know the proof for the derivation of the equations. All you need to know are the equations. So we have 3 equations now that relate to the refractive index. So we've got, first of all, Snell's law, which is the one that we came across first of all in this booklet, which is n2 over n1. Remember, n1 is usually 1, so it's usually just n equals sine theta 1 over sine theta 2. We also now can relate the refractive indexes and the speeds. So n2 over n1 equals v1 over v2. And again, sometimes you'll just see it as n equals v1 over v2 because n1 is usually 1 because it's air. And refractive index and wavelengths, n2 over n1 equals wavelength 1 over wavelength 2. So in summary, n2 over n1, or sometimes just written as n, is equal to wavelength 1 over wavelength 2, which is also equal to speed 1 over speed 2, which is also equal to sine theta 1 over sine theta 2. So you've got quite a lot of you can find out quite a lot of information if you know the refractive index. Remember, wavelength 1 is the wavelength of the wave in material 1, and wavelength 2 is the wavelength of the wave in material 2. Speed 1 is the speed of the wave in material 1, speed 2 is the speed of the wave in material 2. And theta 1 is the angle in material 1, and theta 2 is the angle in material 2, which is usually the angle of refraction. Okay, so note that when the light is refracted, the frequency does not change, really important. The speed changes, depends on the medium, and the wavelength also changes. So there's an example there. You can see the wavefronts in the air. So wavefronts are just if you're looking at it from sort of a bird's eye view, you see the wavelengths change, but the frequency does not change. So work example 3. A beam of monochromatic light of frequency 4.85 times 10 to the 14 hertz passes from air, so N1 is air, 1, into liquid paraffin. In liquid paraffin, the light has a speed of 2.1 times 10 to the 8 meters per second. First of all, calculate the refractive index of the liquid paraffin. So part A. So what do we know? So we know we want to find the refractive index in the liquid paraffin, so N2, because it's going from air into liquid paraffin. We also know because it's going from air, N1 is just 1. We don't know anything about angles. We do know, however, the speed of light in air. It doesn't give you in the question, but you just have to know it. 3 times 10 to the 8. And the speed in paraffin, it tells you in the question, is 2.10 times 10 to the 8 meters per second. Okay, so we've got speeds and refractive indexes, so we can use one of our new equations, n2 over n1 equals v1 over v2. Just make sure you get those numbers correct. So n2 over 1 is just n2 equals 3 times 10 to the 8, the speed of light in the first medium, so the speed of light in air, divided by 2.10 times 10 to the 8, which is the speed of light in paraffin. And that comes to 1.43. And again, it's just a number, so it doesn't have units. So 1.43. And part B is a trick question. What is the frequency of the light when it's in the liquid paraffin? The frequency does not change, so it's the same. So frequency does not change. I apologize. I decided to give it the ghost in the middle of this. So it's just the frequency in the question. So 4.85 times 10 to the 14